This video covers the concept of interference. So waves can interact with one another, which means that several waves can travel through a single point at once. Interference is the word that we use to describe when waves interfere or interact with one another. In order to show how waves interact, the sum of their displacements or amplitudes is going to equal the resulting wave's displacement or amplitude. So let's assume that we have two identical waves here traveling towards one another. Since both waves are above the x-axis, when they interact, their summation causes the wave to double in their original height. And once the wave passes through this single point, they continue on their way. This process where the displacement or amplitude increases is called constructive interference. You may be asking yourself, what happens when one wave is above and one wave is below the x-axis as shown? When these combine, their summation of the displacements actually ends up equaling 0, and they cancel each other out. And the resulting wave is actually no wave at all. But once the two waves pass through this single point, they continue on the way. This process, where the displacement or amplitude decreases, is called destructive interference. So let's do a few examples. On the left, we have several different oddly shaped hypothetical waves, and we want to see how they would interfere with one another. So let's look at the first example. We have two different square blocks above the x-axis coming towards each other. Since they are both above the x-axis, they will constructively interfere, and the resulting wave will look like this. The second example has two different squares, but one above and one below the x-axis. When these two waves interfere, they will destructively interfere, so the resulting wave will look like this shape. Alright, and the third example has a square and a triangular wave. Since they are both above the x-axis, they constructively interfere, and the resulting wave is just a square with a triangle on top of it. And lastly, the fourth example has a square and a triangular wave, but on opposite sides of the x-axis. So this resulting wave will look like a square, but with a triangular chunk missing.